So let me give you an example of a PET study. This is looking at blood flow changes in visual regions, in primary visual cortex, in response to the presentation of visual stimuli. So it's a very simple task. Subjects just fixate centrally, on a screen, and they, for all of these studies that utilize these imaging technologies, you need, of course, a control condition and then an experimental condition. So the control condition here, the subject just looks at at the screen, just stares at the screen, right? Just a blank screen. So when you're just staring at a blank screen, there is going to be activity, there's going to be blood flow in your brain, obviously. So, and this radiolabeled chemical that's been injected is going to be circulating in that blood. So you're going to get a signal. So this is your sort of baseline signal, right? And you're going to subtract this signal from your experimental conditions, like when you actually present something visually to the subject. So if you present something at the central fixation cross, they presented a checkerboard, right? So kind of a visually arresting stimulus at the fixation point. You see, when you subtract out, the general blood flow under the control condition, heightened blood flow, right? This is more decay of, radioactively, let's say is oxygen that was injected into the blood, O15, at this location, right? And then as you move the checkerboard, right, you actually move the blood flow changes, around the brain. So this is a functional imaging technique. It's giving you pictures that are telling you something about which areas of primary visual cortex are, focusing on or responsible for information, visual information coming from different portions of your visual field.